This lesson is on the development of the law of cosines. So like we did before when we developed the law of sines, what we want to do is try to tie this triangle, which may or may not be a right triangle, into what we know about right triangles. So let's go ahead and I'm going to just draw a height here down to side C. So that perpendicular, I'm going to call that H. Now, when I look at that, I've got now two right triangles that I can use the Pythagorean theorem on. The problem is that these two sides of these two right triangles are not all of C. So what I have to do is, if I call this one X, I'm going to call this one C minus X for this part of the side. Now, let's use our Pythagorean theorem. I'm going to, over here, do the Pythagorean theorem for this triangle. So what I get is x squared plus h squared equals b squared. For this triangle, what I get is h squared plus c minus x squared equals a squared. Now, in both of these two triangles, I have an h squared, so let's get that by itself. So in this first one, I'm going to have this become h squared equals b squared minus x squared. On this one, I'm going to go ahead and subtract this from both sides, and I get h squared equal to a squared minus, and I'm going to multiply this out. I'm going to expand it. And when I expand it, I get c squared minus 2xc plus x squared. And now I've got two things equal to h squared. Let's set them equal to each other. I'm going to move over here, and I'm going to go ahead and set this here, a squared minus c squared, and I'm going to distribute through that minus, plus 2xc, and then minus x squared. I'm going to set that equal to this b squared minus x squared. Now, let's simplify this and then use what we know. So we've got a minus x squared on both sides, so if I add x squared to both sides, that's gone. So I've got a squared minus c squared plus 2xc equals b squared. Now we come to the point where we have to deal with this x. That x is an unknown. It's a value that isn't part of our original triangle. So let's relate it back in this triangle here. So I'm going to go with this triangle here, and I'm going to relate that x to what I do know in the original triangle. That x, if I look at angle A, that's the adjacent side. So cosine of angle A is equal to the adjacent side x over the hypotenuse b. So if I multiply by b on both sides, x is going to equal b times cosine of A. Now what I can do is I can substitute that back in over here. Let's go ahead and do that. So I'm going to have a squared minus c squared plus 2 times, and I'll put this in its place, b times cosine of A times c equals b squared. Now, what I've got here is a lot of information, but I'm going to get the a squared by itself and put everything else on the other side, just because it's going to look very familiar to when we have the form of what's called the law of cosines. So I'm going to have a squared equals that b squared. I'm going to add c squared to both sides. And then I'm going to subtract this 2 times b times c. Notice I'll bring that c and commute it over in front. So 2 times b times c times cosine of A. And this is what we call the law of cosines. If you have an angle, you have the three sides, you can set up this law of cosines to find out if you're given three sides, the angle, or if you're given an angle and two of the sides that surround it, the angle is included between the sides, you can find the missing side. That is called the law of cosines.